Hello everybody. Welcome to my DP600 labs. Analyze data in using Apache Spark in Microsoft Fabric. I'm on time. Let's get started. I'm just going to share my screen. So let me share my screen. And I hope you see my screen. And here I'm just in my Microsoft Fabric environment. So just I typed app.fabric.microsoft.com and I got there. Today, what are we going to talk about is just analyze data with Apache Spark in Fabric. So all the labs are available in Microsoft Fabric documentation, and I'm just going to share the link for you so you can find it in chat box. So I have already shared the necessary link. So in this lab, we are going to ingest data into the Fabric Lakehouse, and we're going to use PySpark to read and analyze the data. And roughly, this lab will take approximately 45 minutes to complete, but I will try to do my best to keep it a little bit shorter. So everything, as we did in the previous labs, starts with creating a workspace. So now let's create a workspace. So here I say workspace, new workspace, and I'm just going to call it like Apache Spark. So let's say just a minute. Apache Spark WS, and for description I say lab purpose only, and here in advanced part I have to be sure that the trial is selected and I say apply. Thus our first step has been completed. So actually we are waiting, so let's wait for a while, and then of course we'll go on with our second step. Okay, let's wait for a while. And in the next step, we are going to create a lakehouse and upload, files to this lakehouse. So I don't know the reason that it takes more time here. So let me do it once again. So workspaces, new workspace, and let me call it Apache Spark WS, and maybe so there is nothing. So let me refresh it. It's the first time that I'm facing with challenge like, yeah, we have this one, Apache workspace. So it has been already created. Now it's time to create a lakehouse and upload files. So for this purpose, here I'm going to find create button, and in data engineering part in lakehouse, I'm selecting this one. Pardon, and I'm saying Apache Spark underscore lakehouse. This is the lakehouse that I have created. I'm creating, and say create. And in few moments, my Apache Spark underscore lakehouse is going to be created. So this is Explorer part of my Apache Spark lakehouse. Now I have to upload files. So we can it's available for us now. So there are several ways to do this, but we are going to upload a folder of text files to our local computer, and then we'll upload it into our lakehouse. So there is a specific, say, link that I'm going to say share it with you on my YouTube channel. I'm in chat box. So let's come here and let's paste this link, and the folder that are going to cover all the necessary files is going to be downloaded. So I'm going to show you these files. So this is what we get. Actually, I have done it. So the next step is to extract all these zip files. So right click on mouse, say extract all, and this folder is going to be extracted. So say extract, and we have to be sure that this folder covers three text or CSV files. So 2019, 2020, and 2021. So this is what we got. I can close it. So after extracting the zipped archive, so we are going to return our lakehouse. Actually, we are there. And now I'm going to upload these files. So from files, ellipsis, I say upload, and I say upload folder. So let me select my folder, and this is my folder. I'm selecting, and I say upload. Say upload and upload. And I have to be sure that this has been checked. So it means that I have already, uploaded the file. So this is the proof of uploading the files. Now we are going to with the next step, which is creating a notebook. So let's create a notebook. We can do it. So let's do it. So here, once again, I say create, and in data engineering section, I'm going to select notebook, and notebook one is by default is a given notebook name, and it's in the Apache Spark workspace location. So say create, and this notebook is going to be, created. So here I can change the name of my, notebook. So let's say, let's give a name, Apache Spark underscore notebook. This is my new name. So yes, we have changed this one. Now, what are we going to do is just, we're going to so just edit this, this part of our notebook. So for this purpose, I say this one, convert to markdown cell. And here I'm going to select this one, and I'm going to copy the necessary words and type here, Control V. Actually, yes, let's see. Control V and like this. Yes. So we see this one. Sales order data exploration. Use this notebook to explore sales order data. Now it's time to create a data frame. So let's create a data frame. So we have created a workspace, a lakehouse, and a notebook that we are ready to work with our data. Now we are going to use PySpark, which is the default language for Fabric notebooks, and the version of Python that is optimized for Spark. Pardon. So there is a note like Fabric notebooks support multiple programming languages, including Scala, R, and Spark SQL. So let's go to left part of our, Windows, screen. So let's select our workspace. So this is our newly created workspace. And let's select this Apache Lakehouse. Here we see its Explorer. And now we are going to select this one, orders. So here we have this orders file. And the next step is just adding, to the right part of this window, our notebook. So to do it, what should we do? We are going to say open notebook and existing notebook. And we select newly created notebook. Thus, we see this window. So let me select this one. My files, orders. So we have in the left, most left part, I have my Explorer, my files, and my notebook. So after doing this, I'm going to select 2019 CSV file, ellipsis, load data, and I'm going to say Spark. Now we see this automatically created code. So by the way, we can also, hide this button, but I'm not going to do it. Then after creating this code, I can run this code. And when the cell code has completed, we are going to see some outputs, but our session is still in process. So let's wait for a while and we're going to see, output. So let's see what the output is going to show us. So it's roughly 26 seconds. So let's wait for a while. And most probably this output will show data from 2019 CSV file, from this file, and it will be in columns and also in, rows. So I don't know today the reason that it takes more time. Actually, it was very smooth. Maybe it's due to my internet connection speed. But let's wait for a while and let's see, what we get at the end of the day. So then we'll have a lot of codes to, apply. But actually, by the way, all the, codes have been have been written on the Microsoft Fabric documentation, the link that I shared with you. So in this case, most probably what I'm just going to do, I'm going to delete this one and I'm going to do it once again. So that was my code. Let's say new code and Control V and let's do it. And let's hope that it's going to be done in seconds. If it's not, yeah. Or once again, I'm going to, just delete it once for one more time. And here it's still, running. So yeah, let me done it. Session is ready, and I'm going to once again say load data, Spark, and run. I hope this time it will take less, less time. So this is the output I got. And here I have to pay attention, to one stuff. Actually, first row of my data is shown as column name. So I have to fix this one. So how to fix this one? We have to write one more, code. So let's say code and Control V, enter. And here I'm going to say display df, data frame, right? And say run. And we are going to check the column names and just pay attention. Now it's a little bit different. The column names have been shown like C1, C2, C3, so on and so forth. So our code worked. Now we have to, make some changes because we know that descriptive column names may help us make sense of data. And to create meaningful column names, we need to define the schema and data types. And also we need to import a standard set of Spark SQL types to define the data types. So, sorry. So let's write one more code. Actually, once again, this code has been, written on Microsoft, these labs documentation. So let's say code and Control V, and just pay attention from PySpark SQL types import, and this is our order schema with the data types, and say run. Okay, so here we see, with meaningful column names, the output, right? So we have sales order number, sales order line number, order date, customer name, email, so on, so forth. Okay, so this data frame includes only the data from, 2019 CSV file. So we are going to modify this code so that the file path uses asterisk wildcard to read all the files in the orders folder. So let me copy the necessary code and let me paste it here. So this is what we were talking about, and say run. So when we run this modified code, we should see sales from 2019, 2020, 2021. So here only a subset of rows is displayed. So to see, pardon, all the years rows may not be available. So if we click here, or if we scroll down our mouse, there are a lot of data, it will not be easier to see all the years data. Okay, and now let's go on with our next step, which is about exploring data in a data frame, right? So the data frame object provides additional functionality such as the ability to filter, group, and manipulate data. So we begin with filtering a data frame. So let's go down. And here we select this code. And by the way, if we don't find this one, we should go to edit, and from edit we can select add code cell below just to add one, code line, right? So now we're going to write a code that is going to filter the data so that only two columns are returned. It also uses count and distinct to summarize the number of records. So let's copy this code and let's paste here and let's run this code. So it still runs. So here it counts. This is the outputs of counts. And this is the output that we get at the end of applying the above code, right? So briefly, this code creates a new data frame called customers, right? Customers, and this is the customers, the name of data frame that includes customer name and email. And so another way of achieving the same result is to use the select method. So let's also do this. Just let's remember this output, customer name with email. We can do it using select method. So let's say code and Control V. So customers, df select customer name and email. Let's run this code and we'll get the same output, right? Actually, action is ready. So here, what should we say? We should say enter display, I think customers, right? Customers. So I hope we'll get the same, results. Yes, output. It works. And the data frame functions count and distinct are used to provide totals for the number of customers and unique customers. Now, so we can modify the first line of the code by using select select with a where function as follows. For example, we can give a specific, filter. So let's say, just pay attention here. I say that df select this one that equals to this one. And if I say run, we'll get all the output that is going to be related to this item, right? Now, a little bit about aggregation, grouping data in a data frame. So let's add the following code to our notebook. And it's about product sales, df select item quantity, group by item, and sum. So it means that it's going to give us output that will show us the sum of order quantities grouped by product, right? So this is what we can see. We can add another code to the notebook. So let's add it. And let's pay attention from PySpark, SQL functions import from all files, yearly sales, and let's display also this one. And here we see, just say orders count, number of orders by years. So let's give some explanation. So import statement enables us to use Spark SQL library and select, pardon, a method is used with SQL year function to extract the year component of order date. And the alias method is used to assign a column name to the extracted year value. And the group by method groups the data by derived year column. And the count of rows in each group is calculated before the order by method is used to sort the resultant data frame. Now we're going to use Spark to transform our data files. And a common task for data engineers and data science is to transform data for further downstream processing or analysis. And we can use data frame methods and functions to transform data. So let's add the following code. Let's do it, Control V. And here we create year and month columns. We create the new first name and last name fields. We filter and reorder columns. And at the end of the day, we display the first 5 orders. So let's run this code. So we will be seeing that, year and month columns added based on order date column, first name and last name columns added based on the customer name column, and the columns are filtered and reordered, and the customer name column, removed. So this is what we get after applying this code. So we can use Spark SQL library to transform the data by filtering rows, deriving, removing, renaming columns, and applying order data modifications, right? Now it's time to save the transformed data. So at this point, we might want to save the transformed data so that it can be used for further analysis. And Parquet is a popular data storage format because it stores data efficiently and is supported by most large-scale data analytical systems. Indeed, sometimes the data transformation requirement is to convert data from one format, such as CSV, to Parquet. So to save the transformed data frame in Parquet format, we should add cell and add the following, code. So let's add it, code, and Control V, transform df write mode, Parquet, and print. So after running this code, we are going to see a message. So it says that transformed data saved, right? And I hope if we go here, we should see this, transformed data folder. But so for this purpose, I hope let's refresh all the tables and, we see this one, transformed data. And this is what we get, right? So let's add the next code, Control V, and let's run this code. So a new data frame is, created from the Parquet files in the, transformed data orders folder. So from here, and we should verify the results show the order data that has been loaded from the Parquet files, right? And now it's time to save data in partitioned files. And when we deal with large volumes of data, partitioning can significantly improve performance and make it easier to filter data. So let's add the next code that is going to partition the data by year and month. So let's say code and Control V and run. So let's wait for a while. And it still runs. And after running, so we are going to, we're going to refresh the files. So session is ready. So let's refresh here. And the folder contents is, are loading. Actually, it should give us the output like year equals 2019, year equals 2020, year equals 2021. But before this demo, I practiced this lab. Unfortunately, I didn't get it. But anyway, it's going to give us, an output, right? So, pardon. And once again, I don't know the reason that it takes a little bit more time. And session is already ready. So I'm going to, just refresh it once again. And I hope I will get the refreshed output. So, uh, so this is what I got, so let's select this one, files and orders. Yeah, this is the output that we got, but actually, once again, it should be like, year equals to 2021, so on and so forth. So it doesn't matter. This is the output we get, and it means that our transformation, transformed data saved, and yeah, we got the necessary, the necessary, we got the necessary output, right? So now we are going to add one more code where, will help, which will help us to load the new data frame from the orders, from here, Parquet files. So let me copy this one and let me add code and say Control V and just pay attention, orders 2021 data frame, right? It's this one, and it's going to, load the data from this file. And let's verify that the output shows the data for 2021 year. So this is what we get, and we verify it. Okay. So in this point, I'm going to, with next step of this demo, which is about working with tables and SQL. We have seen now how the native methods of data frame object enable us to query and analyze data from a file. However, we may be more comfortable working with tables using SQL syntax. And Spark provides a meta store in which you can define relational tables. And the Spark SQL library supports the use of SQL statements to query tables in the meta store. And this provides the flexibility of a data lake with the structured data schema and SQL-based queries of a relational data warehouse. Hence the term data lakehouse. So let's create a table, and tables in a Spark metastore are relational abstractions over files in the data lake, and tables can be managed by the metastore or external and managed independently of the metastore. So let's add the next code to the notebook that's going to save data frame of sales order data as a table named sales orders. So let's do it. Control V and say enter. And here we have one note. In this example, no explicit path is provided, right? So the files for the table will be managed by the metastore. Also, the table is saved in Delta format, which adds relational database capabilities to tables. This includes support for transactions, row versioning, and other useful features. And creating tables in Delta format is preferred for data lakehouses in Fabric. So we run this code, and it describes the definition of the new table, right? And it still runs. So yes, this is what we get, right? And now we are going to back Explorer pane, and we are going to table ellipsis and say refresh, and we should see sales orders table that has been created. So this is what we get, right? Okay. Now let's go back to our orders file here on Explorer. So yeah, so here on sales order table, I'm going to select ellipsis and load data and say Spark, right? And we get this, code, and let's run this code, and it's going to, use Spark SQL library to embed a SQL query against the sales order table in PySpark code and load results of the query into a data frame. So this is what we get. Now we're going to run a SQL code in a cell. While it's useful to be able to embed SQL statements into a cell containing PySpark code, data analysts often just want to work directly in SQL. So let's add the following code here. Control V and say enter. And here, just pay attention, double percentages SQL. This is the command at the beginning that we see, changes the language to Spark SQL instead of PySpark, right? And the SQL code references the sales order table that we created previously, and the output from the SQL query is automatically displayed as the result under the cell. So this is what we see. And now we can visualize our data pardon, with Spark. So charts help us to see patterns and trends faster than would be possible by scanning thousands of rows of data. And Fabric notebooks include a built-in chart view, but is not designed for complex charts. For more control over how charts are created from data in data frames, use Python graphics libraries like matplotlib and seaborn. So we're going to view results as a chart. So for this purpose, we're going to use this code in SQL. Select from sales orders and say run. And we get this one, right? So here I'm going to select new chart. And I'm going to do some stuff. So yeah. And I say build my own. And I'm okay with bar chart, right? And for x-axis, I'm going to select item. For y-axis, I'm going to select quantity. And for series group, I'm going to leave it as blank. For aggregation, I'm going to use sum. And missing and null values display as 0. And stacked is unselected. This is what I'm getting, in chart format. So we can start with matplotlib. So let's write the code. And you see SQL query. So, and I'm going to run this code. And it's going to return a Spark data frame containing the yearly revenue for years, and of course the number of orders. So to visualize the data as a chart, we'll first use matplotlib Python library. And this library is the core plotting library on which many orders are based and provided a great deal of flexibility in creating charts. So let's add one more code. Let's do it. And this is the code. So say Control V and say run. So let's see what the result is going to be, with. This is the result that we get. And it, covers the total gross revenue for each year. And the matplotlib library requires a pandas data frame, so you need to convert the Spark data frame returned by the Spark SQL query. And at the core of the matplotlib library is the pyplot object. This is the foundation for most plotting functionality. And the default settings result in a usable chart, but there is considerable scope to customize it. So let's do it. For this, we're going to write one more code. So we say clear the plot area, create a bar plot of revenue by year, customize the chart, and show the figure. So let's run it. So we should see this output, right? And a plot is contained with a figure. In the previous example, the figure was created implicitly, but it can be created explicitly. So we can modify the code to plot the chart as follows. So let's say code, Control V, And let's run this code. And we see this one, right? And the figure determines the shape and size of the plot. And the figure can contain multiple subplots, each on its own axis. So modify the code to plot the chart as follows. So let's do it. Control V. And I'm going to, run this one. So we get this output, right? So it's much more interesting. So now I would like to talk a little bit about using the Seaborn library. While matplotlib enables us to create different chart types, it can require some complex code to achieve the best results. For this reason, new libraries have been built on matplotlib to abstract its complexity and enhance its capabilities. One such library is Seaborn. So let's add the necessary code here. Control V and import Seaborn as SNS. So let's run this one and let's see the output, right? So of course we are going to modify this code. So code still runs. So this is what we get, and we can run the previously written code. So let's do it. Control V and say run. And we get this one, right? This is our new output. And here, Seaborn enables us to set a color theme for our plots. One more code is going to be written. So let's see, Control V. And it's going to create a line chart, right? And we're going to view the yearly revenue as a line chart. So this is what we get. So in these exercises, we have learned how to use Spark to work with data in Microsoft Fabric. So if we have finished exploring our data, now we can end Spark session and delete the workspace that you created for this exercise. So here we have, standard session. We say, for example, we don't see anything, or run all. Here we see, actually I hope should do it from here. So this is what we get. And after, stopping the session, we can delete the workspace. So here under run, we have stop session. We should do this one, and session stopped successfully. And if we go to our workspace, this is what we get in our workspace. So what we have done till now, lakehouses and notebook. And from workspace settings, we're going to delete our workspace. I don't know, the workspace is, something that relates to workspace today is working a little bit slowly. So let's say remove workspace, and we're going to delete this workspace, and everything everywhere is clear. So I'm just going to, stop sharing my, screen. So this is all about this lab. Today at 4 p.m. by Baku time, I'm going to demonstrate one more lab. So see you then. Thank you for joining, for watching my video. Thank you.